Section 4.3 Understanding Standard Deviation. 4.3 Beyond Standard Deviation. Let's explore two more advanced risk measures: Conditional Value at Risk, CVaR, and Expected Shortfall. Conditional Value at Risk, CVaR. Conditional Value at Risk, also known as CVaR or Expected Shortfall, is a risk measure that extends the concept of value at risk, VAR. While VAR quantifies the maximum potential loss at a specified confidence level, CVaR goes further by considering the expected loss beyond the VAR threshold. CVaR represents the average of the losses that exceed the VAR threshold. It provides an estimate of the average or expected loss given that the loss exceeds the VAR. In other words, CVaR measures the average size of the losses when the portfolio performs poorly, beyond the VAR level. CVaR provides a more comprehensive assessment of the tail risk and the potential magnitude of losses during extreme market conditions. It helps investors understand the potential severity of losses beyond the VAR level, which can be valuable in risk management and portfolio optimization. Expected shortfall, also referred to as conditional expected shortfall or tail conditional expectation, TCE, is another advanced risk measure that addresses the limitations of VAR. It focuses on quantifying the average or expected loss beyond the VAR threshold. Expected shortfall calculates the expected value of the portfolio's losses given that the losses exceed the VAR level. It represents the average loss beyond the VAR, taking into account the tail distribution of returns. By considering the entire tail of the distribution, expected shortfall captures the magnitude of potential losses more accurately than VAR. Expected shortfall is particularly useful in risk management as it provides insights into the potential magnitude of losses in extreme scenarios. It helps investors understand the expected size of losses when adverse events occur and allows for a more comprehensive assessment of risk. Both CVaR and expected shortfall enhance risk analysis by going beyond the singular point estimate of VAR and considering the distribution of losses beyond the threshold. They provide a more comprehensive view of downside risk and assist in managing portfolios in extreme market conditions. It's important to note that CVaR and expected shortfall, like other risk measures, have their own assumptions and limitations. They require historical or simulated data to estimate the tail distribution accurately. Additionally, the choice of confidence level and the underlying assumptions can impact the results. It's advisable to use these measures in conjunction with other risk measures and perform sensitivity analysis to gain a robust understanding of portfolio risk. In summary, CVaR and expected shortfall are advanced risk measures that provide insights into the expected magnitude of losses beyond the VAR threshold. They enhance risk management and assist in capturing tail risks and extreme events, helping investors make more informed decisions in managing their portfolios. Conditional value at risk, CVaR, and expected shortfall have several applications and benefits in risk management. Capturing tail risk, CVaR and expected shortfall focus on the tail of the distribution, where extreme events and large losses occur. These measures provide a more accurate representation of tail risk compared to traditional risk measures like standard deviation or VAR. By considering the potential losses beyond the VAR threshold, they capture the severity of extreme events and tail events, which is crucial for managing downside risk. Portfolio optimization, CVaR and expected shortfall can be used as risk measures in portfolio optimization. When constructing portfolios, investors often want to balance risk and return. By incorporating CVaR or expected shortfall as objective functions or constraints in the optimization process, investors can explicitly account for the potential downside risk and aim to minimize the expected losses beyond a certain level. Risk monitoring and stress testing. CVaR and expected shortfall provide valuable tools for risk monitoring and stress testing. These measures allow risk managers to assess the potential losses under adverse market conditions or extreme scenarios. By analyzing CVaR or expected shortfall over different time horizons or stress periods, risk managers can identify vulnerabilities in portfolios and take appropriate risk mitigation actions. Risk reporting and communication. CVaR and expected shortfall provide intuitive risk metrics that can be used in risk reporting and communication. These measures help communicate the potential magnitude of losses and the severity of extreme events to stakeholders, such as investors, regulators, or board members. They enhance transparency and enable more effective risk discussions and decision-making. Tail risk hedging. CVaR and expected shortfall can guide the selection of appropriate risk mitigation strategies, such as tail risk hedging. Tail risk hedging involves strategies like purchasing put options or employing downside protection instruments to limit the potential losses during extreme market conditions. CVaR or expected shortfall can help identify the level of protection needed to manage tail risk effectively. Regulatory compliance. In certain financial sectors, regulatory requirements mandate the use of advanced risk measures like CVaR or expected shortfall. For instance, banks and financial institutions may be required to calculate these measures for assessing capital adequacy, stress testing, or risk-based pricing. The benefits of using CVaR and expected shortfall in risk management include a more accurate assessment of tail risk, enhanced risk monitoring, improved portfolio optimization, and better communication of potential losses. By incorporating these measures, investors can make more informed decisions, better understand the downside risks in their portfolios, and effectively manage their exposure to extreme events. However, it's important to note that CVaR and expected shortfall, like any risk measures, have limitations and assumptions. They rely on historical data or simulated scenarios, and their accuracy is subject to the quality of data and the appropriateness of the underlying assumptions. It's advisable to use these measures in conjunction with other risk measures and perform sensitivity analysis to gain a comprehensive understanding of portfolio risk.